All right. Well, welcome everybody. I'm very glad to see your names and faces for today's webinar. I'm so excited to see so many people interested both in our webinar topic today, sharing lessons learned in the New Jersey pilot projects, and broadly in the topic of beneficial use for ecological restoration. So my name is Adriana Zito Livingston. I work for the Nature Conservancy's New Jersey chapter. I've been working as part of a multi-agency planning team broadly focused on advancing the practice of beneficial use for ecological restoration through knowledge sharing and learning with activities over the past year. But more on that in a moment. So as we begin, a few standard housekeeping things for our Zoom meeting today. We ask the participants remain muted through the panel discussion and most of the remarks today. Feel free to leave your video on or off, depending on your personal preference. So there are too many of us, thankfully, for individual introductions, but feel free to introduce yourself in the chat by indicating your name, organization, and the geography in which you work. I think we have a pretty broad range today, which is really exciting. And alternatively, you can add if you know how to change your name on Zoom, go ahead and do that to reflect your organization. So we realize that it's a little unorthodox, but we're actually not leaving time for your questions today. There have been questions that have been voiced in previous sessions that we're trying to address today, but it is not that we're not interested in your questions. We certainly encourage you to ask questions and utilize the chat to do that. So we'll use these questions, the ones you put in the chat, to develop our next planned learning exchange, which will be a deeper dive into the Avalon and Fortescue projects. So that's going to be coming soon to your inbox in early December. So look for that meeting notification soon. If you can't wait till December, go ahead and feel free to reach out to our speakers directly, but please respect that they are incredibly busy people and may take a few minutes to get back to you. So just a quick rundown of today's agenda. So I'm going to share a little bit more with you about this learning exchange effort, then introduce our moderator and panelists, and then we'll spend the remaining time on an interactive exercise using Jamboard. We're counting on all of your input as we build an efficient and effective learning exchange going forward. So what is the Beneficial Use Learning Network? So I'll run through just some opening comments on where it comes from, what the need is, what's happened so far, what are we hoping to do together, what are we hoping to deliver, and how you can help. The beneficial use of dredge materials is not a new practice. It's been successfully done on the West Coast and along the Gulf of Mexico, but in the Mid-Atlantic, beneficial use for ecological restoration, especially in tidal wetlands, is a relatively new and innovative approach. In our region, stakeholders from conservation and dredging sectors have been discussing this topic with increasing frequency, and a modest number of beneficial use projects have actually been implemented. So interest has been sustained, at least in part, because if we can get this right, restoration could be accomplished at a much greater scale, at a time when our coastal habitats and communities are under increasing pressure to adapt to climate change. It's abundantly clear from all the talking and thinking we've been doing together in various work groups, technical advisory committees, and restoration planning efforts that we need to continue to collaborate and work intentionally to understand and advance this practice before taking it to scale. So intentional knowledge sharing and tech transfer between practitioners of constructed projects and practitioners who are planning and reviewing future projects can not only increase shared understanding, but accelerate innovation and improve project outcomes over time. So that's certainly our sincere hope. The current learning network effort has origins, though not exclusively, from two different recent efforts. The first is a series of 3 beneficial use practitioner working sessions that were developed by a steering committee from the New Jersey Delaware Salt Marsh Working Group. Those were held last spring, and they focused on identifying priority learning topics, which is how we got here today, and creating an initial summary of knowledge gleaned from on-the-ground projects, primarily that happened in New Jersey and Delaware. The second was actually where we got our invite list, and many of you may have attended the full-day virtual workshop hosted by Forsyth National Wildlife Refuge, where multiple sectors engaged in learning about restoration tactics, planning tools, and challenges for beneficial use projects. Though perhaps not their core purpose, those previous events were leveraged to develop this event kind of as a course needs assessment. And the Learning Network, this effort, aspires to address some of those learning needs directly. So over the next year, we're hoping to facilitate knowledge sharing and tech transfer In the near term, we're going to be doing this through proposed, using completed and proposed projects as learning platforms. The Planning Committee has developed today's webinar and our efforts thus far. We plan to follow today's webinar with a series of project-specific retrospectives, where we'll work with project teams and focus on priority learning topics to mine transferable knowledge and foster discussion. So those are going to be deeper dive conversations. Today is just a teaser. The first retrospective, as I said, is going to be happening in early December, and it's going to focus on some of the same beneficial use projects that you're going to be hearing about in just a few minutes. So we recognize that there are a lot of working groups out there. We all attend a lot of meetings, and we did not take the decision to form a learning network lightly. While the Learning Network by necessity has an organizing committee, this effort is less about the people involved and more about intentional knowledge transfer and building a shared understanding of an innovative practice. So working together with a shared goal and clear deliverables in mind, we can strengthen the practice, be more innovative, and develop resources to summarize and share the state of the practice, which is hopefully a really exciting prospect for everyone. Our ultimate goal will be to be better prepared to leverage the sediment resource to its fullest potential and be able to implement ecologically responsible restoration projects for habitats and our coastal communities. So we're actively shaping this effort, and we'll be working in the next month to clarify goals, and we're counting on your input as we do so. So we're kind of launching this as we form. You can begin today by giving our panelists your full attention, documenting your questions in the chat. There are no stupid questions. And more importantly, sticking around to participate in the Google Jamboard exercise so you can provide us feedback and directly inform this effort going forward. And if you'd like to volunteer to join the organizing committee, definitely reach out to me or indicate so in the chat. All are certainly welcome. Without further ado, I'm going to launch us into our panel discussion. So I'd like to invite Mattia. Mattia is a research scientist with NJDEP's Division of Science and Research. And we're going to start. Thank you, Lisa. So we're going to share some slides. Mattia is going to introduce us both to the 3 focal projects for today's discussion and the recently released Lessons Learned report. So take it away, Mattia. Thanks for being here.
Thanks. So Lisa, I think right now you're showing the presenter view. So maybe swap. There you go. Thank you. Okay. So you can switch to the next slide there. Thank you. So today I am briefly going to go over the need for pilot projects, talk about briefly what the pilot projects are, and then also talk about the lessons learned and report that just came out so that you know what the content of that is. So these pilot projects were the combined effort of many, many, many different people and funding sources. The New Jersey Department of Environmental Protection worked with Princeton Hydro, Greenvest, ERDIC. We got funding from the EPA. We worked with the Army Corps of Engineers, New Jersey Department of Transportation. We received Hurricane Sandy funding from the National Fish and Wildlife Foundation, which got funding from the Department of the Interior. We worked with the Nature Conservancy, Rutgers, the Wetlands Institute, and many others. So I know that we will be mentioning this later on, but one of the major lessons learned for us was that it takes many partners to make successful projects happen. So in 2013, the Division of Fish and Wildlife, which is part of New Jersey DEP, partnered with the Army Corps of Engineers, both the Philadelphia branch and ERDIC, the New Jersey Department of Transportation, the Nature Conservancy, and Green Trust Alliance to initiate 3 pilot projects that would advance the concept that beneficially using dredge material to increase the elevation on existing but stressed salt marshes would increase the abundance and cover and health of native salt marsh vegetation and result in an ecological uplift that would ultimately increase their resilience to accelerating sea level rise. As you are all, I'm sure, aware, we are concerned in the state and in the region that our tidal wetlands are not keeping pace with sea level rise. So all of the parties acknowledged that this was an opportunity to explore a paradigm shift from treating dredge material as a waste to treating it as a valuable environmental resource. We all agreed that retaining sediment within the estuaries provides more environmental benefits than the traditional methods of disposing of the sediment in confined disposal facilities, which are like sort of like a landfill for sediment. The hope has been that by combining navigational dredging projects with habitat enhancement projects, both will become more feasible and hopefully more cost effective. However, in order to further develop this method of marsh enhancement, it was recognized that pilot projects were needed before this became a standard practice in New Jersey. And we wanted to have some local proof of concept examples. You can go on to the next slide. Thank you. So the projects were implemented between 2014 and 2017. We have projects in the Atlantic coast in Avalon and Middle Township. The Middle Township site we call Ring Island, and then Fortescue over in the Delaware Bay Shore. Our main focus for developing the projects was on marsh enhancement, but the projects also included other habitat types because we had more sand in the channels than we wanted to use for the marsh, and we had to be sure to clear the channels as well as do the marsh enhancement project. So multiple goals. But for today, we'll be focusing more on the marsh portions of the project. The general goals of the marsh parts of the project were to increase marsh elevation in order to create high marsh, to increase the cover of native salt marsh vegetation, and to have no lasting negative impacts. While all of the projects shared these goals, the starting conditions of the sites and the enhancement activities at the sites were somewhat different. So we have a lot of different things we could learn from them. Next slide, please. So our first site was at Ring Island, and that's located in Middle Township, right near the Wetlands Institute. The marsh portion of this project tested our ability to spray fine grain sand over an even 3 inches in one area and 6 inches in another area on the marsh. Next slide, please. At Avalon, we experimented with pumping and spraying fine grain sediment into expanding pools. The idea was to fill them enough to revegetate them and then to give the surrounding area of the marsh a small elevation boost. This was done in 2 phases, a sort of pilot phase one winter and then a larger project the next summer. Next slide, please. At Fortescue, we used a more elaborate pipe layout with multiple exit points that could be turned on and off. Again, we were looking for thin layer placement, and the sediment was a mix of fines and sands and even some gravel. Next slide, please. So in addition to implementing the projects and monitoring them, it was important to DEP and TNC and our partners to carefully document and report out on what we did, why we did it, how much each section cost, and the lessons learned along the way, so that we could help people to build better projects in the future. We did not expect that we would hit everything exactly right the first time around. And so we wanted to really carefully document what we were doing. The reports, this is reported out in two different documents so far in terms of large reports and several peer-reviewed publications. So the reports are the main lessons learned report, which is about 150 pages long. And I know Adriana provided links to that in the invitation, were collaborations between DEP, TNC, Greenvest, and Princeton Hydro and the Wetlands Institute. And it was reviewed by the Army Corps of Engineers and by New Jersey DOT. And so it very carefully, there's a lengthy summary section that we expect non-practitioners to read, followed by bulleted lessons learned, some of which we'll be talking about today. And then there's another 100 or so pages of carefully documenting exactly what we did in each phase of the project, from identifying the sites and putting the projects together all the way through monitoring at the end. And then we're working on a monitoring report. Right now, we've been working on it for a while, as you know. That should be out in the next few months. And so we'll be excited to share all of that with you. And I think that's it for me for background. Thank you.
All right, I think I can take over here. Thanks, Mattia. I'm Mitch Hartley. I work for the U.S. Fish and Wildlife Service and the Atlantic Coast Joint Venture, which is focused on coordinating and facilitating bird habitat conservation on the Atlantic coast. I'll be moderating the discussion with the 4 panel members and give each of them an opportunity to respond to a series of questions related to their area of expertise and role on these 3 projects. The goals for this discussion are to allow our panel to share important information from the lessons learned report and to whet your appetite for the upcoming Avalon Fortescue retrospective, where we'll dig a little deeper on project results and address any questions you may have. So I'll start by welcoming the panelists. We're grateful that you're all here today to share your expertise with us. Please take a moment to introduce yourself, including your role on these projects, and report out broadly and briefly from your perspective. How did it go? Please also share the top lesson learned for your phase of the project. And we'll address panelists in order of phase, starting with Mary, and then Joel, Monica, and then Mattia. So Mary, I'll turn it over to you.
Thanks, Mitch. My name's Mary Pace Goldman, formerly with Princeton Hydro, and worked as the primary design engineer for the various projects. I focused primarily on the design phases of the work, and we developed the design drawings that ultimately led to implementation at the Avalon and the Fortescue site. With the Avalon site, we focused primarily on expanding and degrading pool areas and focused on placement of material in those areas to reach targeted design elevations. Those design elevations were dictated by placement using the equipment anticipated for the project and then anticipated water content so that we could ultimately reach a different elevation at the end of the dewatering period. We also designed containment measures to hold the material in place and avoid any sediment loss back into the waterways, including the tidal creeks and channels. And then at the Fortescue site, we did the same thing. However, we were working in that situation with more containment cells, as well as a beach and dune replenishment area at that project site. So similar metrics were used for both. With the Avalon site, we worked with the Army Corps of Engineers as the primary dredge supplier. And then at the Fortescue site, we worked primarily with New Jersey Department of New Jersey Department of Transportation. With both of the sites, the plans were focused on a target design elevation that was dictated by ecological biobenchmarks, and we focused on detailed specifications and drawings to accomplish those targeted goals. The biggest lesson learned for the Avalon and Fortescue sites was the fact that some adaptation needs to be made in terms of management of the site when you get out to construction. There are limitations with the different types of equipment that the contractors utilize at the sites, and that makes a big difference in terms of what can actually be achieved, in addition to constraints such as weather and things where survey elevations may have been taken on frozen ground, and then that obviously results in a different elevation when you get out to construction if the ground is no longer frozen. There's a lot of variation that can, very subtle, few inches and millimeters can make big differences in terms of the overall placement. So that's probably the largest lesson learned on the design and implementation side from the overall implementation for the projects at Fortescue and Avalon.
Thanks, Mary. Joel?
Good morning. I'm Joel Piccoli. I'm a research scientist in the New Jersey Department of Environmental Protection. I'm currently in the Bureau of Environmental Evaluation and Risk Assessment in the Site Remediation Program. But at the time these projects were being designed and constructed, I was in the Office of Dredging and Sedimentary Technology. And my main role then was to write the permits for these 3 projects. But I think I can probably speak for everyone that was on the project team that even though we kind of each had our little focus and our little silos, so to speak, we worked in, everybody was pretty much involved in all aspects of the project from the get-go, from design through construction, even into monitoring. The biggest, how did it go to answer that question? Well, you can see the slide there that permits were issued. So from that perspective, that was a win. I was involved and some other projects that were proposed, similar projects in New Jersey the past few years. And as far as I know, none of them really got permits. I'm not sure what really happened to them because I'm not in that office anymore. So from a win situation, we did permit these projects in the somewhat shortened timeframes that we required to do so because of the Fish and Wildlife Foundation grant requirements. Biggest lessons learned, I think, are two. The first, which Mattia alluded to earlier, was that we had a very diverse and comprehensive project team. And you really need that to do these kind of projects, not only from the wetland restoration aspect of it, but you need the dredgers involved also. And because they have to put their input into these projects. Both the dredging project needs to have certain objectives that have to be met, and the wetland restoration project has objectives that have to be met. And the two of them have to be consistent with each other, or you not be able to do the project, or you run into problems along the way. The other thing that Mary alluded to was adaptive management. You really need to be able to be flexible and adjust the project and the construction and the monitoring as these projects are implemented. Again, because you have a dredging component and a restoration project, but also, as we saw in these three pilot projects, things will happen you didn't expect to happen. You have to be able to adjust to them because of weather or because of any multitude of factors. I think I'll leave that at that and move on.
All right, Monica.
Hi, good morning, everyone. My name is Monica Chaston, and I'm with the Army Corps of Engineers in Philadelphia. I am a coastal engineer and a project manager in our operations division. So I just have a few slides to kind of talk about our role in these projects. And as many of you know, we manage the federal navigation channels in coastal New Jersey and Delaware. Talking today, we're going to be talking primarily about the New Jersey Intercoastal Waterway and two projects at Avalon and Ring Island that we did using dredged sediments from there. Fortescue is actually managed by, I think Mattia mentioned, New Jersey Department of Transportation. Scott Douglas would be the contact for that project. You can go to the next slide, please, Mitch. As part of our authorization for federal channels, we go to the state of New Jersey as the non-federal sponsor, not for a cost share, but to provide placement areas to the Corps of Engineers. So what we've been trying to do over time, especially post-Irene and post-Sandy, is stop placing material into confined disposal areas and really kick up our program in terms of beneficial use and placement on marsh restoration, shore protection areas. Next slide, please. So some of our first, I would say, in this current era of beneficial use projects for the Corps of Engineers came after Hurricane Irene and then subsequently Hurricane Sandy. I have the first three initial, what we were calling pilots. We've kind of gotten away from that language now. Mordecai Island was a mixture of sand. Avalon was a new one for us. It was predominantly fine-grained material. And then Ring Island and subsequently Great Flats was mostly sandy material. So this is a key slide as we're learning. Typically in the Corps, we design our own dredging and placement projects. We've been working a lot through our ERDIC, our R&D lab, and also the other districts that do a lot of beneficial use to come up with those dredging and placement projects. Next slide, please. So how did we get involved and kicked off in this one? I have to give complete credit to Dave Golden. At the time that we were looking to dredge the New Jersey Intercoastal Waterway, we had prior placement areas in the Avalon and Stone Harbor vicinity. We wanted to use those again. Dave serving as the state as the non-federal sponsor for providing a placement area. There was great habitat where we had prior placement areas. So he had the foresight to say, we want to partner though on a different area, and that started off with the Ring Island and Avalon areas where we started working together, as Joel and Mattia mentioned, on other projects, coming up with new pilot projects. Since then, we've been able to do a whole, I think 5 projects since we did these 2 initial pilots. So as far as lessons learned, I would say that One of the biggest lessons learned for us is to really work with the whole concept of engineering with nature and regional sediment management techniques that allow us to kind of not over-engineer projects, but look at the entire system and use some of the natural processes to move the material on the placement areas. Another big lessons learned is managing risk. I think we can manage some of the risk. These first pilot projects, we were all a little bit risk averse because they were new to us, especially Avalon being fine grain material. And I think we can manage that risk with adaptive management built into the projects. And for us, monitoring and adaptive management as the Corps of Engineers is something that we can tackle. The last slide, please. I just wanted to kind of put in perspective. This is the section of the New Jersey Intracoastal Waterway near the Avalon project. What we want to see as the people managing the channels is that blue on this drawing. So we were looking at a channel that was completely red when we started the project for Avalon back in 2014. It has taken multiple marsh restoration placement areas to actually get us to this part of the blue channel. So it's been 7 years of working to try and clear that channel. And I'm going to just end there. Thanks for your time on the first question, Mitch.
Thanks, Monica. So Mattia, back to you.
Okay, thanks. So I've been involved in many aspects of this project, these projects from the beginning, but my primary roles have been in helping with site identification, documenting and reporting out on the project, and then coordinating and participating in the monitoring. And I would say that for the monitoring and site assessment, I have kind of combined lessons learned from that. One is that for monitoring permanent plots, we installed permanent plots before we constructed the sites, and that ended up being really very useful over time because the sites after sediment was placed on them were very heterogeneous, and being able to track the same plots over time was beneficial. The other thing that we did as part of the adaptive management related to monitoring was to add regular qualitative monitoring. So we just went out and checked on the sites and kind of assessed how they were doing over time to see if they might need adaptive management. And that wasn't part of our formal original monitoring plan. So it was something that we had to add afterwards. And we would recommend other people do that and plan for it. I think that's all for now. Thank you.
All right. Thank you. So we'll move on to our next question, which is an important cross-phase lesson learned shared in the report is that beneficial use restoration projects have long timelines, and it's necessary for both construction and ecological objectives to be achievable within the project timeframe. So the question is, how did the project timeline impact your perception of the projects? Is it reasonable to anticipate shorter timelines for future beneficial use projects? And please say why or why not. And so we'll go in the same order, starting with Mary.
Thanks, Mitch. So from a project timeline standpoint, there are certain portions of the design phases that really can't be expedited. You know, first and foremost comes the marsh assessment and selecting the placement areas. And quite a bit of data goes into that collection phase. And, you know, typically that takes upwards of a year to a year and a half to gather the requisite information to document that that is, in fact, the area where the placement will go. From there, the design tends to take not as long as some of the other pieces, because usually by that point, the design goals and objectives have all been already established. So then it's just a matter of production of the drawings towards that end goal. But permitting then, which I know Joel will speak on in more detail, is something that really, as the design team, we can't anticipate exactly how long that will take. You know, there have been some progressions in terms of both the federal and state agency permitting for restoration focused projects. And so they are working to try to, you know, accelerate the review times for these types of projects. However, it still can take, a fairly lengthy time at the review stage. During the design phase, there's also quite a bit of implementation that needs to be undertaken in terms of coordination logistics with the dredge contractors and the dredge team. And so that also adds to the overall timeline. These projects, any restoration project takes, a lot of planning and preparation, and then a lot of time at the back end on the implementation side. So we don't really think that there will be a way to necessarily improve the overall timeline in the future. Obviously, some of that will, depend on the actual conditions for the site that you're looking at. And there's flexibility, depending on the scale of the project too. If something's smaller, sometimes that can be done more quickly. And then something larger and more complex obviously takes longer. But I don't envision from a design and sort of data collection standpoint that we would really expect to see anything accelerate in the future. I think this is pretty standard for these types of projects. I'm going to turn it over to Joel.
Thanks.
Mary summarized things pretty well. From the permitting perspective, again, one of the big factors affecting the timeline is how complete a project you have before you first submit the permits. So that takes all the data assessment, all the design, all that upfront work. And really, again, emphasizing this project team, you want to be working with the regulatory people from not only the department, but also the Corps of Engineers, because you have 2 sets of permits to get for most projects, to make sure that when you are going to submit your projects, that there's a reasonable chance that they're going to approve them without requiring major revisions. So that leads to a lot of upfront data collection assessment work, not only for the restoration project, but also for the dredging project, and to make sure that the 2 of them are in sync and can work together. Again, this is, you're seeing on your screen the table 2 from the lessons learned document. We hashed this out, the project team, trying to figure out realistically what was a reasonable time frame. And again, I agree with Barry. I don't really think you can get too much shorter than this. Again, this starts at conception from, time equals 0. So if the smaller projects, again, you don't need to collect as much data. The dredging projects are simpler to address. More complex projects, they're going to take longer to assess, to collect the data, to design, and even the bidding and contracting process could be, simpler project takes, a smaller project takes a less simple bidding and contract procedure sometimes. Construction, I'll let Monica talk about that a little more, but that, weather can jam you up on construction. So I think really this is pretty much realistic, and I don't really see any ways to shorten it too much.
All right, thanks, Joel. And Monica?
All right, so my mind's all over the place on timelines. So working in operations division within the Corps, our timeline tends to be a very short one. Our funds will drop in quickly to dredge the channel, and we may have 6 months to implement them. So we have to think sometimes more quickly. So that's why we're so involved with our R&D lab and our regional sediment management program, to be setting things up in advance of an actual project or project funds dropping in. So I would say that we are advancing and getting our designs, put that in quote, out more quickly. Through the years, we've been doing lease of plant, which is rental type contracting, which allows us to work directly with the dredge contractor on the placement areas. And some of the projects that have come up since Avalon and Ring Island, we are really increasing our knowledge and our tools in our toolbox in terms of techniques like using Y valves, optimizing the sprayer and the spreader methods, and different things like that. So I think as we're working with the dredging industry and our ERDIC lab to be collecting data, not just in advance of one project, but throughout the region for the 7 Mile Island region, I think that's improving our timelines for design and placement. In terms of a timeline for construction, implementation, dollars are money. The longer you spend on a project, the longer it's going to cost if we're doing it under a lease of plant where we're paying the dredger by the day. So that is a concern, and trying to increase that or decrease the timeline for actually constructing a project. This year it's a long story, but we were kind of forced into a cubic yard type contract, which tends to be the more typical contract. And those are going to increase the costs and potentially have to, you're going to have a more solid design going into those to bid those projects. And so that would go back to the types of timeframes we were looking at in these original projects. I think I'll stop there for now.
All right, thank you. Mattia?
Yeah, let's see, Lisa, can you advance it to the first vegetation recovery slide? And for me, it's slide 14, but I'm not sure what it is for you. Keep going, I think, one more. So in terms of the monitoring, when we first conceived of these projects and when we were designing them, and I think maybe Mary mentioned that or we'll mention it in the next couple questions, we designed the projects based on some of the literature values that we had seen suggesting that the salt marsh vegetation would survive placement, up to a certain number of centimeters being placed on top of it. And so we expected that 1 or 2 years of monitoring would probably be enough for us to be able to see whether or not we met our goals for these projects. But what we found was that even after a couple of, and this is sort of a teaser for a discussion in December, but even after just a couple of centimeters were placed, most of the vegetation at the sites did not survive. And then the recovery of those sites, the vegetation at the sites was quite variable. So up top we have Fortescue. The sediment was placed in the spring of 2016, and in May there wasn't much vegetation. By August it was growing in. By the following year there was twice as much vegetation. And then basically by 2018, so 2 years after the project was constructed, you couldn't really tell in most places that anything had been done there. Whereas at Avalon, we had, sort of a similar starting condition right after sediment was placed, but the sediment has taken longer to recover. And we still haven't met we've sort of met some equivalency at some of the sites, but we haven't achieved that uplift in terms of the percent cover of vegetation that we're looking for now, 4 or 5 years after the project. So that's just to say that, in order to document that you have met the goals of your project, more than 1 or 2 years of monitoring is necessary from most of our perspectives. Thanks.
Thanks, Mattia. Moving on to the third question. Target elevation is one of the basic metrics of project success for beneficial use projects. However, another cross-phase lesson learned was that it's challenging to estimate the volume of dredge material needed to meet the target elevations. Can you tell us how this challenge impacted each of your roles in the project, along with including how you were able to overcome this challenge? And it would be helpful to frame it as advice you'd give to someone in your position on a future project.
I'll just jump in real quick, Mitch, and say, Mary, there's a slide if you want it with the target placement elevations and ecological elevations, that one, if you want it.
Yeah, that sounds great. Thanks, Mattia. So when we were looking at the Avalon site and the Fortescue site, there was a lot of discussion about target placement elevation versus a target ecological elevation. And this slide sums it up really well for Avalon in terms of what we were looking at. We anticipated settlement of the material after it was placed, but we needed to provide the contractors with clear direction on what elevation we wanted them to meet before they stopped pumping and placing material at the marsh. So the 5 different areas that Avalon had the placement elevations noted here, and then the ecological elevations noted just to the right of those in the columns. We anticipated generally a placement depth of about 9 inches across the marsh plain, with anticipated settlement down to a level between 3 and 6 inches, depending on where we were on the marsh. Obviously, in places in some of the deeper pooled areas, the placement thicknesses exceeded that because we were looking at an overall blanket placement elevation for each of the areas designated. So that was something that was discussed and debated between the ecologists and the engineers to work through in the process of the design. And ultimately, we focused on that sort of anticipated 9-inch thickness across the majority of the marsh plain, with an anticipated settlement down to an ultimate placement depth of between 3 and 4 inches along the vegetation. At Fortescue, again, similarly targeted that 9-inch placement depth with an anticipation that it would settle. The type of material at Fortescue varied from Avalon. We had much finer material at the Avalon site, which had its own set of challenges in terms of the water content and then ultimately the time it took for that dewatering and settlement to take place. At the Fortescue site, much sandier material, so water content was not as big of a concern, and also the settlement was not anticipated to be as significant as it was at Avalon. So that was considered for both of the overall project sites. I think in terms of planning these projects again in the future, more consideration should be taken towards existing pans and pools on the marsh plain, and deciding whether or not we do want to utilize a blanket target elevation as the focus for the placement, or if there can be a little bit more variability in order to maintain some of the diversity of the overall marsh plains rather than the blanket targeted elevation for each of the cells. And with that, I'm going to turn it over to Joel.
Yeah, from the permitting perspective, when you have a dredging project, you have to have a management alternative that can address the entire volume that's going to be supposed to be dredged. That's one issue we have to deal with. And then from the restoration perspective, to permit that project, you need to have an idea of how much dredge material you need to do that project. So the two of them have to work in sync. Again, that's why you want to have a project team involving the dredgers and the restoration folks working together from the get-go. Ultimately, from the restoration perspective, the important number is the ecological elevation. That's what you're trying to restore to, so the plants and the other critters come back to a viable and hopefully a better functioning habitat. But one of the issues you have with achieving that could be how the material behaves once you start actually placing it on the marsh. For example, at Avalon, it was pretty fine-grained material, but once you start pumping it, the sand fraction will segregate out from the fine fraction. The fine fraction starts spreading along the marsh. And just from that practical experience, you need to have people on the marsh monitoring the construction to make sure that if you have target elevations, that they're either not being achieved or that you at least get to the levels you want. The other issue happened at Fortescue really was from the dredging side. When they first did the surveys, we had a fairly good idea of what nature of the dredge material was going to be. But subsequent surveys before the actual implementation of the project showed that it was really more sandier than we thought. I guess they were taken about a year apart, so more material moved into the channel. And what that affected is that we had to change the scope of the project so that we really couldn't do as much marsh restoration as we originally wanted to, because we didn't have suitable material. And then we had to find alternatives for this sandier material, which led to developing the dune project and the beach project. So it's kind of complicated. It can be very iterative. It can change over this whole process of identifying the target placement elevations. Can change as more information is collected about not only the dredging project, but the restoration site. So again, you just need to have that project team and be prepared to change gears and change directions a little bit as you're developing the project. Let's turn over to Monica.
Yeah, thanks, Joel. So I think both Mary and Joel touched on some of these things, but I would say in terms of target elevations for us, it goes back to what we preach initially is sediment testing, understanding the sediment and constructability up front. What can you actually do with the material? Dredging is not precise when it comes to marsh placement. So I think in some of these initial projects, and you see some of the numbers here in hundreds of feet. It's It's not that precise. It's hard to get equipment out there and put some of the men out there, you know, sinking up to their chest in mud to move a pipe to get a different target elevation. So I think one of the things we have learned is we have gotten better results when we're looking at a landscape type design. So like Joel mentioned, in Avalon, we saw, even though it was predominantly fine grain, we saw a portion of the sediment that was sand drop out quickly, and we weren't ready for that. Now we are designing projects to account for that so that we have our target elevations at, you know, the highest elevations where the sand is expected, all the way down to where we believe that the fine grain material is going to run better. And we're trying to use natural processes to move that material. So I think those target elevations, really looking at a landscape design in terms of what you can expect as opposed to one elevation over a big site like Avalon. For a project like Ring Island, where it was predominantly sand on the elevated nesting habitat, it's a lot easier to achieve target elevations when we're working with sand on an area like that. So some of it depends on the size of the site, the type of the sediment. I also made a note here that we have learned so much in terms of consolidation of fine grain dredge material since these initial projects. Our ERDIC team has been working hard on the subsequent areas, Gull Island and Sturgeon Island. And target elevation with fine grain material may take time to get there. So instead of looking at these as one big construction project, we're now starting to look at them as lifts over time, allowing for that consolidation to eventually reach the target elevation. Thanks, Mitch. I'll stop there.
All right, and Mattia?
So yeah, I want to just play off of what Monica was talking about. I definitely agree with what she was saying. And let's see, Lisa, can you go to the slide with the brightly colored orange and green and map? Yeah, that one, thanks. So just to kind of demonstrate what Monica was saying, you know, on average at Avalon, we did a really good job of meeting our ecological elevation targets. But it was highly variable. So some areas consolidated more than we expected. In some areas, the sand piled up more than we expected. So I think Monica's right on about thinking about this kind of more at the landscape level. And there's also a difference between trying to spray material and have it go where it needs to go and reach the elevation that it needs to reach on its own, versus other projects that you may have seen people report on where they're pumping usually sand onto the marsh, either an existing marsh or to recreate a marsh, and then they get out there with little dozers to get the elevation exactly right. When you're just spraying the material, even if you have mostly fine grain sediment, you're not going to end up with that like hitting exactly 2.6 feet, you know, everywhere. You're going to have a variety of habitat types. And I don't think that there's necessarily a problem with that. It's something that we just need to acknowledge. The other thing about this is that these differences are quite small. They are ecologically significant. A small change in elevation can be ecologically significant, but it can be very difficult to reach. Like Monica was saying, you know, with the like hundreds of feet is not realistic to try to place at that. And similarly, from a monitoring perspective, trying to measure those differences has proved to be very challenging. We're not certain that really doing an RTK GPS survey, even though the accuracy of the equipment is very high because of the heterogeneity of the sites and the difficult sort of sinky foot terrain, we aren't really able to measure those types of differences. So that's an issue moving forward. And the last thing I wanted to say about the target elevations is that preliminarily, we think we've seen some trade-offs between the elevation and the recovery of the site. So at Fortescue, we did not reach our target elevations, and that site recovered very quickly. Whereas at Ring Island, in terms of the tidal prism, those placement areas are especially high in the tidal prism, often being above mean high or high water, and they're slower to recover. But theoretically, that extra boost should make the marsh, more resilient into the future in the face of sea level rise. So I think those are some of the things that we really need to talk about as a community moving forward, thinking about the trade-offs of the loss of ecological function while the site recovers, and whether it's better to give it, one big boost, or as Monica said, if it's possible to place smaller amounts of sediment over time. Thanks, Mitch.
Thanks, Mattia. Okay, so we are now at our last question. Several of the lessons learned identified in the document call out the need for flexibility, iterative processes, and adaptive management. What aspect of the project did each of you feel had to be the most flexible, or did you have to be the most flexible on? And how did those changes impact your expectations from the project or the end result? Again, we'd like you to frame this as lessons learned that you'd want to leave the audience with today.
All right, so in this adaptive management section, I mean, I've worked in ecological restoration for many years now, and every restoration project requires some level of adaptive management. It's just part of what we expect working in this industry. Nature's unpredictable. We don't know exactly what's going to happen to a project site from the beginning phases till we get out to construction and implementation. And then we have other factors that have already been touched on today, like weather, differences in contractor styles and contractor equipment. That was a big portion of how things worked out at both Avalon and Fortescue. We had to adapt real time at the Fortescue site due to changes in contractor equipment use that resulted in a significant deviation from the design plans for the placement at that location. Originally, it was anticipated to be placed using a pipe network that was kind of like a Christmas tree shape, actually, and they were unable to accommodate that exact placement plan. So we had to do quite a bit of adaptive management in terms of how the placement was done at the Fortescue site. In addition, at the Avalon site, we had more tidal channels and creeks on the marsh plain than had been mapped in the initial phases, and we needed to install additional containment measures during the placement there. And I know that impacted placement of the dredge materials because we had to stop to make sure the containment measures were fully in place and that we weren't losing the material over the tops of the stacked core logs and other containment measures that were in place at the Avalon site. So, again, adaptive management is anticipated at every project for restoration. You have to be really flexible. I'm used to, getting those calls during construction phase that require that we get out to the site and field modify the design drawings and figure out how we're going to move the projects forward. I don't think these projects in particular were, any more involved than most, with one exception being at Fortescue. We had additional use of heavy machinery on the marsh that wasn't anticipated. So we had to do some additional repair work there that I think could have been avoided had there been a little clearer line of communication with the contractor, just because of the site complications and layers of detail and nuances that go into it, as well as having the very large diverse team that Joel mentioned. We have a lot of stakeholders involved, so a lot of different hands in the cookie jar that need to all kind of be working in sync, and a clearer chain of command, I think, would have addressed some of the concerns that we had in that mindset. I think the adaptive management could have been a little more clearly shared out to all parties involved and agreed to by everyone before we started on implementation to address some of those concerns. But ultimately, again, every project has this adaptive management. I think it's really important for project success, and that clarity in terms of who's taking ownership and responsibility for the various pieces during the implementation phase becomes really critical, and who's ultimately making the decisions and how that hierarchy works is also effective. So I'm going to turn it over to Joel for his thoughts on adaptive management.
Thanks.
Mary was pretty comprehensive there. I'm not sure I have all that much to add. But you're just stressing you need adaptive management to be flexible, really from soup to nuts on these projects. One thing I would add is, because you're going to need adaptive management budget for it, put money aside to handle those unexpected situations that'll arise, whether it's during the assessment phase when you find something you didn't expect to find, or you need to do multiple surveys. To the very end, when you're monitoring the permits, I think from both the department and I think from the Corps also, they usually have success criteria over a certain time frame. Usually, for example, it might be 85% vegetation recovery over 5 years. If that doesn't happen, you have to go out and adjust the project, maybe do more planting to meet those success criteria. So as I say, budget for the adaptive management. One of the things that was really useful, Monica's mentioned the lease of plant contracting process they've been using. That provided a good deal of flexibility during the construction phase, which the typical dredging projects don't. The dredgers, when they're paid by cubic yards, they want to get in and out of there as quickly as they can and as efficiently as they can. We were fortunate with the dredger that we were working on at Avalon and Ring Island that they understood what the project was. They understood what the marsh restoration goals were. And they were very flexible and worked with us very well. But they were able to do that flexibility because they had the lease of plant contract. If they didn't have that, I'm not sure they would have been quite as flexible. So I'll leave it at that and turn it to Monica.
Thanks, Joel. That's a good transition. Definitely for us, this lease of plant structure where we can move the dredge along 117 miles of the New Jersey Intercoastal Waterway. Again, I mentioned and Joel mentioned that means the dredging company gets paid by the day. So that allows us as the Corps of Engineers to be a little more flexible in accepting the risk. If we, in the case of Avalon, Jackie John was another big player in this whole project. She would be out on the marsh saying, oh, I think an area is filling up too fast. We need to either slow it down, pump an hour on, hour off, or shut down for 6 hours. These are things that we all had to learn on this initial project in terms of accepting risk altogether. What could we all live with, and how could we then turn that into the actual operation of construction? Not only did we have the lease of plant contract to build in that flexibility, but like Joel mentioned, and I have to give credit to Barnegat Bay Dredging, they have been working this waterway for so many years, and they're passionate about making sure that they do a good job along the waterway. So they had ownership of the projects too. I mean, they're trying to perfect techniques and work on innovation. But again, lease of plant allowed the Corps of Engineers to accept the risk and the cost of doing some of that innovation. I put down, what do we have to be most flexible on? I think winter conditions, all of us on this panel can probably say it's probably the coldest we've ever been in our entire life, standing on top of dredge material in January and December, and with snow hitting. And I think that's something that we all have to think about moving forward. We have to abide by windows and work within windows, but being flexible in the winter is very, very tough because you have humans out there doing the work. So we have to think about some of that. I think that's still a challenge. The more we can construct in at least the post avian side of September, maybe September through November, the better. And the last thing I'll just end with is in terms of flexibility. You've heard a lot about adaptive management. There was a colonel in San Francisco district when we were talking about all this that came up with a quote that adaptive management puts controls on known risk. So I think it comes back to managing flexibility and managing risk at the same time. If one part of any of this is so rigid that it can't accept some flexibility or some risk, then that kind of puts an obstacle into the whole project. And I think we don't have to restate it here, but Adriana probably said some of it. The alternative of doing nothing on some of these marsh restoration projects is not acceptable anymore. We're trying to keep up with the pace of sea level rise and climate change. So doing nothing is not an alternative moving forward. We want to use this dredge material beneficially. So I think that comes back to how much risk can everybody accept to build in more flexibility into the permits, into everything moving forward. I will just add one more note on that too. I feel like as the Corps of Engineers, we're able to bring that flexibility and also the monitoring through various groups, and the Wetlands Institute has been really helpful moving forward on some of the other projects that we're doing in the Innovation Lab, and all of you, many of you on the phone are in that working group. Not everybody has that ability, but I think the ability to continue bringing the science and monitoring will also help us build in that flexibility moving forward. What can we all live with? What have we learned over the last 10 years or so? Thank you, Mitch.
Thank you, Monica and Mattia.
So I think I agree with what everybody has said so far. I think so one of the things that Joel mentioned at the beginning was how beneficial it was to have all of these different partners. And we had, many different partners from many different fields. And one thing I think that sets these projects a little bit apart from other environmental restoration projects and from other dredging projects is that we have to accomplish both goals. We have to get the dredging has to be done. Monica and her group has to be able to achieve their goals for the project. And then the ecological folks have to be sure that they are meeting their goals for the project. And so with a project team that's that large and with so many different goals for these projects, we came up with this framework just as an example. And so this is not meant to be a rigid framework, but it's meant to lay out, if we meet goal 1, then we will be able to meet goal 2. And if we meet goal 2, then we'll be able to meet goal 3. And then laying out some of those assumptions. And that's not to say that there isn't flexibility to deviate from this, but it lays out a framework so that everyone on the team, everyone from the dredgers to the regulatory folks to the environmental folks understand what we're trying to do, how we are expecting to achieve that, and what the assumptions are, so that when we do need to adaptively manage things, it's easier to see how that will affect the next thing down the line. So hence like kind of a results chain. And by doing that, I think it'll make it easier for people to be able to see when changes are made, how it will affect those 2 goals, the dredging goal and the environmental goal. So just to give you an example of one of these on here, we have the construction goal is to hydraulically place certain number of cubic yards of dredge sediment on the marsh to elevations that are between X and X over X number of acres. And so the assumptions there are that sediment can consistently be placed to target elevations in the design area, that the dredge pipe layout can be implemented as planned, that there's enough time for dredging to allow for downtime due to weather and dewatering and other issues, and that the sampling of channel sediment was adequate to know what the grain size will be for the project. So by laying out these assumptions, then you say, okay, if we do that, then we can meet ecological objective 1 by year X after construction. The marsh elevation stabilizes to between this range and elevation. And then there are examples and assumptions, and that takes you all the way down then to the end where you meet your overall project goals. So in this case, a more resilient marsh, which is defined by X, Y, and Z, and having a clear navigation channel, which is defined by X, Y, and Z. So this is in the lessons learned and project report document, and we encourage people to use a framework like this when they're designing their projects, and to make sure that every member of the project team is familiar with it, and so that everyone's on the same page. Thanks.
Thanks, Mattia.
And that concludes our questions. Thank you so much, panelists and moderator Mitch. I appreciate everyone's insight. I get really excited when we start to just even see the tip of the iceberg on the things we've learned from these projects and as they were implemented, and then the things we've learned since. And I just see so much potential in intentional transfer of knowledge so that every project builds on the last, and we can only get stronger and have a wider toolbox, as Monica referenced. I'm keeping my comments really brief, but I hope everyone will continue with us in this learning exchange and continue to engage with us. So we're going to take a deeper dive. As I said, I appreciate everyone who's added questions into the chat. We're going to take a deeper dive in Avalon, so look for those emails from me. We are also actively recruiting for the organizing committee for this learning exchange. So if you think it's really important that we learn certain things, please make your voice heard, both in communicating with us and on our Jamboard exercise. So at this point, I'm